Today we are discussing the electronic cooling. We are discussing the various methods. First we start with the air cooling. What is this air cooling? Air cooling is the first air cooling method. Air cooling is the simplest and the most general method of the electronic cooling, and this tends to make use of the cooling fans or the devices such as blowers, which blows over the surfaces of the heat components with the intent of hot air. An example you have always seen in your desktop as well as in your computer. So, air cooling is fairly easy, cheap and effective for number of applications. However, the air cooling does come with some disadvantages. Probably the most important thing is that the noise created, which is the particularly noticeable when high speed and multi cooling fans are incorporated in the relatively high performance electronic cooling runs. So, this is overwhelming in the offices and the home theater, which lower the noises levels are preferred. So, there are the various type of the cooling. So, another type is the heat sink. Another type is the, here we are having the liquid cooling. So, liquid cooling system provides the localized cooling in the electronic devices by transferring the heat to the liquid and the heat exchange or dissipation to the atmosphere. So, heat pipe extends the heat sink fins. The distance and the gravity can be used advantageously in this design. The vapor flow in the opposite to the liquid flow along the wall tubes. So, modern electronic devices requires a significant cooling. So, heat dissipation increases or as a device temperature increases. So, maintaining the some temperature requires the liquid coolant to sustain a refrigeration cooling system. So, some coolant we require to cool down the electronic devices. The way of improving the heat transfer of the electronic devices: number 1, optimum design for the cooling devices. Number 2, enhance the heat transfer. These are the two basic points for the heat transfer of the electronic devices. So, however, integration of the cooling system is available for thermal management, but they are not efficient for the higher thermal management. So, you can see these are the liquid cooling devices. So, we keep in the electronic, and these type of the coolant, they contain the coolant, particular coolant. So, liquid cooling entails the applications of liquid coolant around and on in the liquid form in order to absorb the heat away from the hot electronic components. Typically, we just have the liquid cooling system comprises a pump, a heat exchanger and a system of the tube and a channels through which the coolant is pumped. So, a cooling devices have the various parts in which we are having a pump, heat exchanger, system of tubes or the channels through which the coolant is pumped. So, you have seen in this we are having channels of the, and here in these pipes, in this the coolant is flow, so that it can keep the device cool. So, among the methods of the cooling system, liquid cooling provides the user with the several benefits as compared to the air cooling, like that it is having a higher cooling capacity, higher thermal conductivity and the ability to focus the particular hot spots of the electronic devices. And this is an efficient method for the enhanced application like data center, gaming, PCs and power electronics. Nonetheless, the setup of the liquid cooling system is rather bare and complexity is associated with it and is expensive and requires a lot of maintenance than the air cooling system. So, there are also carry the disadvantages of liquid hoses, leaks which can damage the part of the electronic component operated on. Another type of method is the thermoelectric cooling. That is the thermoelectric coolers creates the heat flux between the junction of the two different type of the semiconductors through the Peltier effect. So it means when we are using a more semiconductors in many electronic devices, most of the semiconductors we are using in the electronic devices. So thermal cooling is required for that. So the thermal cooler creates the high flux between the junctions of the two different type of the semiconductors, which is generally known as the thermoelectric effect. We all know that we are having a two junction, that is a thermoelectric effect. Like the cooling instrument, also called as the Peltier heat pumps or the thermoelectric cooler. So it transfers the heat from one side of the device to the other with the consumption of the electrical energy. So TEC, thermoelectric cooling, are compact and having the no moving parts, offer great potential to enhance the cooling rate of the electronic module and other electronics. So tech, if we see that TEC can also be integrated into the electronic packages for their hotspots, means we can keep this device in the particular position in the electronic circuit. So the thermoelectric materials is work based upon the Thomson-John Seebeck effect and thermal energy to electric energy conversion, that is the thermal energy to electric energy conversion. It is having the option that here by using the thermoelectric cooling we can convert the heat dissipated or the extra heat to convert, that is the thermal energy to convert into the electrical energy. So TE module can transport heat which can produce the electrical current between the two electrical connection sites. So by using the thermoelectric cooling we can convert the thermal energy into the electrical energy. So the one side, the other one side is the, in this process one side is the cold side and the other side is the hot side. The hot side is attached with the electrical circuit, whereas the cold side is attached with the heat sink. So therefore more heat transport through the heat sink and it will result into the more output voltage. So this device is also the environment friendly and also we can reuse of the energy by using this device. So you see on the screen here we are having a thermal electrical setup which is having the you see the heat is absorbed and heat is ejected. In between that we have the electrical conductor as well as we have the electrons hand, that is soldering, and N type and P type, as we are using the semiconductor. So we are having the N type and P type system. So having a one side absorption and another side is the rejection of the heat. So the cooling concept of the tech is shown in the figure. So the simple working principle of the tech makes them the popular in the many application. So the main component of the tech is an array of the two dissimilar conductor, where basically we are having a P type and N type. So first voltage is applied to the free end of the two different conducting elements, resulting in the current, that is a DC flow through the P and N semiconductor. So the flow of current across the junction of these semiconductor generates a temperature difference. Because of this temperature difference, Peltier cooling causes heat to be absorbed from the vicinity of the cold plate and move to the heat sink and to the devices. So among the advantages of the tech over the compressors include no moving parts. We are having a high reliability, environment friendly and safer due to the absence of any refrigerant, and it is having a small size and feasibility of the cooling below the ambient temperature is possible. Another is another thin film tech also offers a great benefit, mainly due to their dramatic enhancement in the cooling power density. So, thin film of we also use for the thermoelectrical cooling. So, some component in the electronic systems and the computers such as microprocessor and the power amplifiers are cooled by these cooling techniques. So, you are seeing on the screen that this is the method where we use this method, and we can have so we can have the various cooling method here, and we are seeing the thermal plate we can use for the thermoelectric cooling. So, here also come to thermoelectric cooling, which is the sum of the Peltier effect, and which is the solid state cooling technology, in which we are having the heat sink effect and is achieved by an electric current put through a thermoelectric cooler, and which heats one side and condense the other side. So, when the current goes through the module, one side of it, which is the cool, which is the absorb the heat, while the other is hot side, that is a hot dissipate heat. So, thermoelectric cooling provides the user with the some particular differentiation points as compared to the result of the methods available in the market. So, it is applied in the cases when the cooling forces is required, such as a small electronic sensor. Moreover, medical apparatus who require this. So, the efficiency of thermoelectric cooling is quite low when compared with the other cooling techniques, and it also requires a lot of electrical power for this operation. So, it is it is also limited quantity of the heat that can be removed efficiently. Moreover, in this thermal electric conductivity, we are having the one of the option, which is the thermal paste. So, thermal paste is a thermally conductive chemical compound commonly used as a interface between the heat sink and the heat source. So, this paste can be used for the cooling. So, this paste is used to improve the heat coupling between the different components. So, a common application is to drain away waste heat generated by the electrical resistance in the semiconductor devices, which including the power transistors, CPU, LED and COP. In the computer, this the heat sink presses the tightly against the CPU. The surface of CPU and the heat sink's contact plate is covered in the tiny grooves and the gaps, and it is not properly sealed up. These gaps allow air to come in between the processors and heat sink, reducing the heat transfer efficiency. This is where the thermal paste can be good fit. So, the thermal paste will be enclosed in that, so which is a good heat conductor, but also it can get into these small gaps and grooves on a surface of the hardware, and this create an airtight seal and increases the rate of heat transfer. Moreover, these paste we can apply for improvement the performance of the devices, as will cool down the device. So, although thermal paste is not a must a boot up computer, and it is very useful for keeping the temperature down, and it is also contributes significantly to prolonging a computer lifespan. Another method in this category is the plate heat exchanger. So, plate heat exchanger offer a high efficient mechanism for the heat transfer, like when taking in various forms including the brazed and the gasketed types. These applications include the water heater, waste heat recovery, heat pump isolation and the thermal storage system. So, you can have the many places where we are having the this plate heat exchanger. And this plate heat exchanger uses the metal plates to transfer the heat between the two fluids. And it usually has a specialized design and well suited to transferring heat between the medium and the low pressure fluid. Means we are having the metal plates, and in between that we are having fluids, and these fluids must be of the specialized material. So we can keep this liquid, this fluid in the plates, and these are welded, semi welded, and the brazed heat exchanger are used where a more compact product is required. Means when we sealed it, then we can get the compact pattern. So these plate uses a plate and a frame heat exchanger are obtained by one piece pressing of the metal placed stainless steel is the commonly used metals for a plates because of its ability to withstand high temperature, its strength, and its corrosion resistance. Whenever we prepare a plate heat exchanger, we use the steel as it is corrosion free, and moreover it is having a high strength or having a high temperature. So we prepare a device by using the steel. So that is a plate heat exchanger. Plate heat exchangers can often be configured in a more compact design, allowing for the easy maintenance and cleaning and to fit in a particular devices. So these are also designed to facilitate easy installation and removal of the plates to expand or reduce its heat transfer capacity. Particular devices have a particular size of the heat place exchanger. So this advantages add value to them as ideal thermal management solution for the small district heating, beverage cooling, food and pharmaceutical production, and the low duty oil cooling applications. Another type is the thermal conductive sheet. In this category, we have a sheets which is also referred as a heat dissipation sheet. Many thermal conductive sheets are made of silicone and acyclic resins. So these sheets like structure is quite flexible and excellent for adhesiveness, so that it can be compatible with the electronic gadgets. So they are widely used for the heat dissipation of the IC chips and batteries installed in the small home appliances and the electronic devices, in combination of the other heat transfer components such as the heat sinks. Heat sinks we will discuss further. So we can combine these thermal conductive sheet with the heat sinks so that we can increase the efficiency of the cooling. So in the IC chips and the batteries produce excessive heat when a device is operated, so that the heat dissipation components are also installed. So the surface of the heat dissipation component attached to the heat source looks seemingly flat, and it is a fine gap grooves allow the air to come in between that. So the installing a thermal conductive sheet between them enables the heat to propagate through the thermal conductive sheet, improving the heat dissipation effect more efficiently. So use of thermal conductive sheet with the high thermal conductivity can eliminate the bottleneck of the heat release, efficiently releasing the heat and reducing the temperature of the heat source, and this result in the further benefit of the increasing the devices and the system lifespan. Another type of the cooling method is the cooling radiators. So radiators is another type of the heat exchanger which is used for the various application including the cars, buildings and the electronic gadgets. So cooling radiators we have also seen in our cars and in a vehicle that we are having a radiator. So how we cool these? So this is for the purpose of the cooling. So now a typical application we can cite it the engine cooling, but in the electronics radiators are also used to cool the CPU and the computers. When we are having a number of systems connecting together, then we have used this. So as a heat exchanger, a radiator transfers the thermal energy from one medium to the another for a purpose of cooling and the heating, and it consists of a large amount of the cooling surface exposed to the large amount of the air so that it spreads through the water to cool it efficiently. So it consists of a large amount of the cooling surface exposed to a large amount of the air so that it spreads through the water to cool it efficiently. To increase the surface area available for the heat exchange with the surroundings, a radiator has multiple fins and in contact with the tube carrying fluid pumped through the radiator. So air or the other exterior fluids in contact with the fins carried off heat. Dirt or damage to the fan could cause ineffective heat transfer. So through these fins the heat is carried out. So this is the benefits of the cooling radiators include more efficient heat removal, effective than the air cooling. Use of the cooling radiators will not just prolong the hardware lifespan, but it also ensured that they are being cooled efficiently at all the time. Another type is the vapor chamber. Now the vapor chamber is a two-phase device used to spread the heat from the heat source to the heat sink. Now the vapor chambers are used when the genuine two-dimensional heat spreading is required. When a single microprocessor or multi microprocessors in a single plant should be cooled. When high heat flux is applied, then we use the vapor chamber. With its design flexibility, vapor chambers are now frequently used in the application ranging from the hard drive, disk cooling, PC cooling, graphic card cooling, server cooling, high heat flux chips and LEDs, and in consumer products, particularly mobile devices such as the smartphones and tablets, and in which we are using the vapor chamber cooling. And a vapor chamber cooling has a metal enclosed that is vacuum sealed and a internal wick structure installed inside and a working fluid that moves within a system, and that is through the capillary action. And in detail, the heat source makes direct contact with the portion of the vapor chamber and finned heat sink attached to the top. So some of the working fluid vaporized and flow to cooler areas. Heat absorption causes the vapor to condense and return to the liquid, which is reabsorbed by the wick structure and distributed to the heat source. And in this method, it will cool the device. So these are some of the basic methods which we use conventionally just for the electronic devices. So emerging cooling techniques based on the effectiveness and the material process adopted in the cooling electronics, emerging cooling methods can be classified into the various types. That emerging techniques we will discuss in the next lecture, in which we discuss the heat pipes, heat pumps, microchannels, spray cooling, phase change material, that is a PCM based cooling. We will also discuss the free cooling, thermoelectric cooling we have discussed. So we will discuss these type of emerging cooling in the next lecture. which these cooling techniques are also very important, and somewhere we use in these cooling techniques according to their utility, according to their application in the various electronic gadgets, so that we can cool the electronic devices, and we can maintain its lifespan, and we can work without hindrance by using these electronic cooling devices. So these devices have a many applications, and we will discuss the various working principle step by step designing, and these are the references we just followed for the preparation of the slide. So these are the basic areas. So now thank you very much. We will further go in detail about the electronic cooling. Thank you.